Our goal is to develop enhanced, improved solution related to charging infrastructure by enabling our broad polymer portfolio and our application expertise. My name is Simone Bottegal, e-mobility marketing manager and lead for our strategic initiative related to charging infrastructure. My role is to work to understand the current and future challenges this market faces and collaborate with industrial leaders to identify their needs. Today, I have the privilege to share the stage with Victoria, my colleague from the Application Development Department.
Hi, I'm Victoria Lee. I lead our electrification efforts within our Application Development Group. Our group aims to understand and anticipate the specific performance needs of a material for an application, and then to deliver value-added solutions to our e-mobility customers. Today I'll be providing the technical explanations for our EV charging solutions.
Let's start with some trends and challenges this market faces today. Global warming and urban pollution drive the needs to increase the charging station market. Car makers are rapidly developing electric powertrain technologies by increasing the range and reducing the total cost of ownership of the vehicle in order to mitigate consumer skepticism. With electric vehicle range expanding and cost declining, the top barrier remaining into the market is the limitation of infrastructure. On one end, people that drive electric vehicles know very well the need to develop and produce, on larger scale, infrastructure that enable faster charging experience, from hours to minutes, that limit availability of accessible and efficient charging points. The second challenge is the so-called charging anxiety, the fear that the car will run out of power before reaching an operable charging point. Well, to summarize, the two main challenges related to charging infrastructure that at the moment limit a larger electric vehicle adoption are faster charging and reliability of infrastructure. As a consequence, building a robust and super-fast public charging infrastructure in order to provide a similar experience of the traditional gas station is a key element for a successful market. Which solutions are currently adopted into the market, and how charging station designers respond to the need of faster charging and higher reliable network. Let me start describing what is existing to the market today. One way to classify the technologies is the level of charging. Nowadays, there are three main levels of electric vehicle conductive charging. The higher the level, the faster the charging, as more power is delivered into the vehicle. The level 1 is the slowest, only dedicated to private charging. It charges through the residential AC 120 volt outlet. An average electric vehicle battery can be recharged in 40 to 50 hours, while a plug-in hybrid vehicle can take 5 to 6 hours. Level 2. Those stations charge up to 240 volt, with some private and, in the most of the case, public infrastructure, like a restaurant, shopping center, and workplaces. Those type of equipment are able to charge an electric vehicle in 4 to 10 hours, while an hybrid plug-in vehicle can take 1 to 2 hours. Both level 1 and level 2 are limited by the onboard charging power capability of the vehicle. The fastest speed, direct current fast charging are mostly installed for public infrastructure, along highway and heavy traffic roads. Those equipments are able to charge an electric vehicle in 20 to 60 minutes. The most of the plug-in hybrid vehicles don't use direct current fast charging. And a side note to consider is that DC power and voltage represent an important challenge to the insulating material for components like cable and plugs.
We have some examples of our charging cables here. A level 2 charging cable is what you might have installed in your home, and it's powered by low voltage AC power. A level 3 charger is what you might have installed in a highway charging station. You can see that there's a huge difference in size and complexity between these two charging cables. In our application lab, we've dissected these and tried to understand what makes a level 3 charger so much more powerful and efficient. In principle, it's all about where and how the current is converted from the grid in AC to the battery in DC. Unlike AC chargers, DC charging stations do that conversion inside a converter in the charging station itself. This means it can bypass the limitations of the onboard charger in the vehicle and deliver power directly to the battery. This results in lower losses that, when combined with the ability to deliver more power directly to the battery, result in a decrease in your charging time from hours to minutes. Level 3 charging cables are larger and heavier because they deliver more power directly to the battery. You can see that the copper power cables are larger in order to be able to handle that extra current, but that extra current generates a lot of heat. So in order to maintain the cable at a reasonable temperature during charging, an innovative inner cooling system has been developed. This is the tubing, where a coolant is circulated continuously in a closed circuit and removes temperature from the high voltage connector pins through a manifold system in the charging station itself. This is the reason why this cable is so much more complex. Let me now explain how we can increase the efficiency of your cooling system. Inside the cooling system, we have different components like connectors, chillers, manifolds, and pumps that are constantly stressed by mechanical, chemical, and thermal loads. Our high-performance materials, like Omnix HPPA, Amidel PPA, and Riton PPS have been used in these types of cooling systems for decades. They can maintain the efficiency of your cooling system throughout the lifetime of the charging station. Typically, the coolant that's used is a mixture of water and glycol, but in some instances, an oil can be used to improve the efficiency of your system at higher temperatures. The durability of your cooling system components can therefore be improved by using our materials, which maintain their mechanical performance even when in contact with aggressive chemicals and high temperatures.
With our solutions, we can support the adoption of efficient cooling systems that enable faster DC charging. In addition, we observed into the market another big factor impacting the charging network nowadays. With the increasing number of stations as a consequence of a broader electric vehicle adoption, it is more and more clear that reliability is a key element affecting the market today. And that's exactly the challenge the market faces today, with one station out of 4 being out of order nowadays. The incremental stress created by higher power and voltages, combined with the need of higher safety margins, create the perfect storm. At the moment, one of the major causes of failure is the quality of material in critical components like charging plug and socket. Considering those parts remain outside, exposed to all weather conditions, and have to withstand to wear, impact drop, and even accidentally run over, we really see how material can make the difference. So, how could the attributes of our material enhance durability and reliability?
Whether building an AC charging system or a DC charging system, there are some key material properties for the charging plugs and guns that you need to keep in mind. These are dimensional stability, mechanical durability and impact resistance, safety, and electrical insulation properties. PA66 is the material that's most commonly used in these systems for the charging plugs and sockets. Our materials, like our Omnix HPPA, Amidel PPA, and Amidel PPA BIOS, pick up significantly less moisture than PA66. That results in less warpage and parts that are more dimensionally stable when used outdoors, resulting in an increased lifetime of your charging station components. Mechanical durability and strength are also critical, as these components have to withstand the daily wear and tear of use. Our materials, because they pick up less moisture, maintain their superior mechanical performance over PA66. Besides durability, other key requirements are electrical insulation properties like comparative tracking index, or CTI, and V0 flammability ratings. With the currents and voltages increasing from AC systems to DC systems, the retention of these properties is more critical than ever for safety and reliability.
Thanks, Vittoria, for the great explanation. Indeed, our solution enables benefit all along the entire value chain. Let me deeper explain why. Charge point operators, which through different type of business model own the charging station, are looking for higher reliable material. in order to avoid costly downtime. In fact, they gain money only if the charging station is operable and drivers can charge their vehicle. In opposite case, their business is impacted by the missed revenue due to the long downtime. Considering in average, they gain $400 per day fully operable, you can easily calculate how much they lose for the long time needed to repair the damage. On top of that, extra costs for repairing can also be avoided by using higher quality materials. All in all, we can really see the comprehensive benefit enabled by our solution in terms of total cost of ownership, which also positively reflects into the reputation of both charging point operator and charging station manufacturers. Moreover, as we already said, one of the top barriers limiting the battery electric vehicle adoption into the market is consumer skepticism, that is also driven by the fear to not being able to reach a suitable charging point when needed. Adopting higher reliable material will also influence in medium term a better market perception, increasing as well the trust in buying an electric vehicle.
Besides improving the efficiency of your system and the reliability of your charging station components, our solutions can also contribute to improved sustainability of BEV charging stations. For example, our Amidel PPA BIOS is made using bio-sourced feedstocks and 100% renewable energy in the US. This contributes to our Amidel PPA BIOS having the best-in-class or lowest global warming potential of any commercially available PPA. In addition, our Omnix Recycle HPPA is made using 70% recycled resin and is another great solution if you're looking to increase the sustainability of your charging plugs and sockets.
In summary, the deployment of faster charging infrastructure and the need to extend the operable time requires advanced materials. Our selection of material for electric vehicle charging infrastructure enable solutions with the outstanding mechanical and electrical performances that enable a higher durability of charging network and increasing the safety and margin condition over the power range. Critical components in electric vehicle infrastructure like charging plug, inner power electronics, and thermal management system rely on our solutions to avoid costly downtime and unsafe margin of operation. With that finalized, I would really like to thank Vittoria for the great technical explanation and all of you for watching this video.
We hope you found this video interesting and informative. If you'd like to follow up on any of our solutions for charging stations, please don't hesitate to contact us.
And now you know how we enable cleaner, safer,
and more energy-efficient mobility.